I do want to watch this one just because it sounds really fucking stupid. And it's from a channel we've never watched before. And it's slightly outside the normal range. So I think we'll check this one out. Disposable vape Powerwall. Probably not a fire hazard. Surely. Surely that's safe. What is the smallest possible EXE? That one actually has been recommended to me a bunch of times as well. Are we sure we're not watching fucking Uwo's lab? This is a good start.
This whole vape collection thing has got completely out of hand. Let's see if we can find a house of these things.
A quick warning before we start. Do not attempt to replicate anything I do in this video.
He's
It covers
British.
some pretty dangerous stuff.
Yeah,
so these ridiculous disposable vapes have actually got fully rechargeable lithium-ion batteries.
Well, they also have a, they also have an entire computer in there. A lot of them have, like, a full system on a chip. They're not disposable. I don't understand how these have managed to slip past any sort of regulation.
Inside of them. And these are the exact same batteries that we use in our phones and in our laptops. But these vapes have been designed to be thrown away after just a single use, which is just completely insane to me. So I've been on a bit of a mission to expose this by building a fully rechargeable power bank and e-bike battery out of them. And now I think I'm going to dial it up a couple of notches. So at their peak in the UK alone, over 1 million of these are being tossed away every single day. And while some places are finally banning them, in most of the world, this is still happening at a mind-boggling scale. So how about we find out how valuable these devices actually are? And can we use them to take this whole workshop, or maybe even my entire house, completely off-grid? So if we wanted to build a massive Powerwall battery pack, how many vape cells would we need exactly? Well, to work this out, we need to wrap our head around battery capacities.
Sure.
So if we have a small cell and it's able to output a power of 1 watt for a whole hour before completely running out, then this means it has a capacity of 1 watt hour. And for reference,
Makes sense.
the capacity of a typical phone battery is about 10 watt hours. Well, I want to build a massive battery that's got a capacity of around 2,500 watt hours. And this should easily be able to power my workshop for multiple days, or even power my entire house for about 8 hours, because my house uses about 6,000 watt hours of electricity per day. So the average capacity of a small vape cell
2.5
is
kilowatt,
1.1
yeah.
watt hours. So to make this thing, we'll need almost 1,400 of these. But the bigger vape cells are about 5 watt hours, so we could get away with only about 500 of them. So in case you've not seen my other videos, extracting these
Analog cigarettes only. Here in India, vapes are banned. Like, vapes entirely? Nothing at all? Do you know why they're banned? Because the tobacco companies don't like them. That's why.
cells is actually mega simple. You just rip off the bottom, pull all the insides out, and cut or desolder the wires from the cell. Now I've just got to do this another couple hundred
and not pierce
or
any
1,000
and
more times.
kill yourself.
You might be wondering, how on earth did I get so many littered vapes? Well, for the smaller projects, I collected them from streets and from festivals, but this would have literally...
How did I get them? I went outside, and they're just fucking everywhere.
taken me years to get enough for this project. But luckily for me, there were some vape shops that take empty customer returns, and they were more than happy for me to take them off their hands, especially as they have to pay out of their pocket to get them disposed. Okay, I'm already seeing a big problem.
How does that discussion go? Hey, so I want to repurpose the lithium cells into a 2.5 kilowatt power bank. Can I take your lithium ion powered vapes? Sure. Yeah, you probably won't kill yourself.
Here, and I've formed a pile of good and bad cells. You see, if a lithium cell ever gets discharged below 3 volts, then it becomes damaged and unusable. And as we can see here, that's the case for about half of these. So they've been discharged way below their minimum capacity. So what I think's happened is, obviously people use these until the battery is completely empty.
Right.
But the circuitry inside here still keeps sipping away very, very
Right.
slowly. And I reckon most of these have been collected way over a year ago. And any that are particularly old, I think the battery has just been drained to the point where we can't really recover it. And this is going to be quite an issue, because if you think that I'm having to throw away about half of these that I still have to crack open and test, that's going to be an awful lot of time wasted.
2 hours later.
Hang on, I'm pretty sure I might have found a solution.
Oh!
So obviously, if you puff on these vapes, if it has battery, it's going to vaporize.
Sure.
As is the case for this one. And if it's out of battery, then it blinks and it tells you that I've not got any more battery. But I found that if it blinks, it means that the battery is still above 3 volts. And if you puff one that is not above 3 volts, nothing happens at all. So if I make a machine that can actually vape these vapes,
Work
then
smarter,
I can
not
rapidly sort
harder.
them into good and bad piles, and then not waste my time harvesting possibly hundreds or maybe even 1,000+ dead vapes. So luckily, I've got a pump from a CPAP machine, and this has the same amount of air pressure as a human lung. So this should actually be perfect for something like this. Let's give it a go. Oh, look at that. There we go, them two working. And this one doesn't. So I should be able to just leave this running and sort through loads of vapes, put all the working ones in a good pile, put all the non-working ones in a bad pile. And we should have halved our workload, really.
Well, it certainly seems that the bigger ones withstand the test of time much better than the smaller vapes.
Sure.
I guess it makes sense, because it's going to take much longer for the internal circuitry to slowly sip away the power of these bigger batteries.
So there's been a recent disposable vape ban in the UK, which is absolutely fantastic.
Good.
And hopefully many other areas start to follow this trend. So the vapes now have to support replaceable pods and have a USB charging port. But it should have been like this from the start, given that USB-C ports cost about 3 cents.
Also, given that a lot of them, again, literally are a computer. It's exactly how I test them. I fix vapes for a few of my friends. So Sorry. You fix vapes for your friends. How did that start? I'm very curious about this. USB-C, yes, USB-C ports are very cheap. Also, you're going to be bulk buying them, so you're going to get them pretty cheap as well. Dang, bro, reflashing lineage to the SIGs. Look, honestly, some of them, again, they are literally full computers. I had a few I was afraid of throwing away, so one day I was curious about repairing one for me. And then my friend, and then I told my friend, and one thing led to another. Awesome. Hey, if that's a nice side gig for you, might as well do it.
But I'm actually a bit skeptical as to how effective this will be, because I've noticed that shops stock way more of the complete kits than just the refillable pods. So people will eventually resort to buying a whole new vape because of the lack of availability of these pods. And the complete kits are about as cheap as the old disposables anyway. But anyway, we're certainly heading in the right direction. So once these cells are removed, we still need to test them to find out their actual capacity. And as we're going to be connecting a bunch of these cells together in parallel, it's really important that they're all charged at the exact same voltage level. And that's why I got 3 of these cell testers here, which will automatically charge them all to the exact same level, and will also measure their capacity so we can group together the cells with similar capacities. So this thing, of course, is made for 8650s,
I know someone's tried to.
Which means we're going to have a pretty hard time hooking up these tiny little vape cells.
Right.
In the e-bike build, we added some crocodile clips to the top, but these were just dangling everywhere, and it kind of spooked me out because they could easily short circuit. So I think we can figure out a way better way so that we can just slot in the cells nice and easy. It's going to save us a bunch of time because we're going to be doing this for hundreds of these cells. So I reckon we can make some conductive spring fins. If we 3D print some small cubes out of flexible TPU and then wrap it in copper tape, then these will be nice and conductive and can squish down to the size of the cell. There we go. These fit beautifully and make a nice solid connection. So now we can get 24 vape cells slotted in, charged and tested in bulk. Once the cell has been fully processed, I write down the capacity on the side of it so that I can then sort the cells into groups of similar capacities. And it's actually really important for the cells to have the same capacity when they're connected in parallel.
Oh my fucking god.
I'm going to focus on just collecting the big ones now, because with the small cells, I'm lucky if I get half of their rated capacity, so I'd need like 2,000 of them. So focusing on the big cells is definitely the way to go. I really don't think this little montage does justice for how stupidly long this cell harvesting process has taken. By this point, we're already genuinely about 2 months in since I started filming. I mean, it takes about 2 to 3 minutes to extract and desolder each cell, so multiply that by at least 600, and then it takes about 2 hours for each batch of cells to then be balance charged and tested. That's the problem with these vape recycling projects. The amount of labour needed is just absolutely massive, and also shows why recycling programs for these things is such an enormous challenge and barely even feasible most of the time. Okay, so we should have around 500 cells harvested now, but when building big projects like these, we always end up needing a bunch of custom parts, whether it's PCBs, 3D prints, or mechanical parts, for example. And finding a reliable place to get them all can be a right headache, which is where JLC PCB comes in, as they offer a true one-stop manufacturing service. So previously I've ordered custom PCBs from
Actually
them, like
a good sponsor for a video like this.
This time, I've used their 3D printing service to make a bunch of modules to hold all the vape cells together. Plus I grabbed a ton of extrusion from their mechanical parts store. Everything came out great.
Brody?
Solid,
that's usually how it goes.
Affordable, and it's honestly saved me a lot of time on this build. They also do CNC machining and full PCBA assembly. So if you're looking for a reliable one-stop manufacturer for your next project, definitely check out JLC PCB. The link's right below the video. Right, so now we've got about 500 of these all extracted and tested. So now we need a solid plan of how we're going to combine them and construct this thing. So to make my life easier and make this thing nice and modular, I'm going to use a 3D print to bundle 9 of the cells together in parallel. This will add up their capacities, so we'll form some low voltage, high capacity modules. We can then group a few of these modules together again in parallel to make an even bigger capacity parallel group of cells. Then we'll need to increase the battery voltage, which is done by making lots of these groups and connecting them in series to then add up their voltages. So I'll stack up 14 of them in series to give us a total voltage of around 50 volts. And there we go. We should have a massive, high voltage, high capacity battery pack ready to go.
Known as a bomb.
So this is going to be pretty enormous. So I think I'm going to build it in 2 halves and then we can connect them together later on.
Alright, so building this thing is going to take bloody ages. So that's why I've recruited some extra help from my friend Max.
Hi, Max.
And he's actually the same guy that's been designing all the 3D prints for the past projects and even these little cell holders. So yeah, let's get started.
Yeah, I have seen that Doom on a vape video in the past. If I remember, I think it was... Yeah, no, that's not actually Doom on a vape. I'm pretty sure it's... Yeah, I'm pretty sure that's the screen share one. So it's like, it's kind of a cheat way to do it, if I'm remembering that video correctly.
Let's have a quick look at how we're going to build these things. So we want to be connecting all these 9 cells within each module together in parallel. And that's why on the negative side, we've just got them all hooked up together using these bus bars. But then on the positive side, usually you would have all the positives linked together and you'd call it a day. But because this thing is going to be powering a literal house and could be drawing a lot of energy and also running for long periods of time, I want to add some extra safety in there.
So instead of directly connecting all
safety.
of the
Okay, yep. Now we're worrying about safety.
positive sides together using the copper strip, we solder a fuse between each cell and the copper strip, meaning every single cell in the pack will be protected against short circuits.
And this idea is kind of semi-inspired by this big old battery pack over here. And yes, I do have way too much lithium in my workshop. But this is a battery pack from a Tesla Model X. And if you look closely, we can see the individual cells here, and they're connected to the bus bars via these tiny little wires. And these wires double up as tiny little fuses. So yeah, if any of the cells are working too hard or have an internal short, these little fuses are going to pop, disconnecting it, and everything else should remain pretty safe.
So it's theoretically just a case of slotting in the cells, putting down some heat-resistant tape to protect the 3D print, cutting some copper strips for the bus bars, soldering fuses between the positive sides of the cells and the bus bars, flipping it over, and soldering all the negative sides together via more bus bars. So only got to do this, what, another 50-something more times?
Not that many.
So we got the first few modules created, and not gonna lie, it looks really quite dodgy. It's like a... Yeah, it really does.
Here we are, we've got 50 something modules finally built, and this should be enough to bundle them together and form 14 parallel rows. Right, so obviously these modules are going to need to be connected together to form the final parallel rows of the power wall. To get them all mounted up, we insert these 3D printed holders into each module, which will let us clip them onto some aluminium extrusion. Then we bolt them down so they're properly locked in place. Yep, these things aren't going anywhere. And then for even more soldering to get these modules finally connected together in parallel. So again, I'm just using more copper strip here to link up these things, and I'm trying my best not to melt the 3D prints too much. Then I flip it over to connect up all the negative sides, and there we go. We've got a row of 36 cells all in parallel now. Then to finish it off, I put some silicone around the cells just to make sure they're held in there properly. And once again, I need to repeat this a bunch more times, 13 to be exact. You know, I'm starting to think this project might not be too good for me, given all the solder fumes and residual vape liquid.
Yeah, that's the problem. The problem is the solder fumes.
Workshop certainly has a weird smell to it.
All right, we're getting pretty close now. So we've got all 14 parallel rows created.
Is this aluminum bent? Wait, you pronounce the L in solder? Yeah, there's an L in solder, so I pronounced the L. What do you mean? What do you mean? That's how you say it.
And I tell you what, these things are looking way cooler than I thought they would do. So we've just got one more thing to figure out before we can finally build a frame for this thing and get it mounted on the wall. And that is, how are we going to hook all these up in series? But I've not really made a nice, easy way to actually connect these together, because we're going to have to connect the positives of one row to the negatives of the next, and the positives to the negatives, and so on. So what I'm thinking of doing is adding a bunch of wires to both the positive and the negative sides with these little clips on them, so that hopefully when they're all stacked up nice and close to each other, I can just clip the positives of one side into the negatives of the one above it, and we just repeat that until hopefully they're all connected together in series and we get a nice
That sounds
voltage.
less dumb than it could have
These wire
been.
clip things are called Wagos, and they're going to make my life so much easier, because I really don't fancy sticking a soldering iron in the middle of a live battery pack while we're connecting it all up in series.
Sure.
And then here I'm using some Kapton tape to insulate the tops and the bottoms of the cell. This is actually super important, because some stray metal could easily accidentally short out some of the inside of the battery pack and start fires. Realistically, this tape isn't quite enough, and I'll add some more insulation later, but I think it'll do for now.
I don't want to hear, I think it'll do for now, when we're dealing with, what, 500 lithium cells.
Right, one half assembled, and this thing is pretty bloody heavy. I mean, I don't know what I expected, seeing as there's literally hundreds of cells here. But yeah, that does weigh more than I thought.
I tell you what, using aluminium extrusion is absolutely perfect for projects like these. Everything just bolts together dead easy, and it is mega strong.
Right, the frame is constructed, and this thing is an absolute unit. So now we need to get these cells finally connected in series. As we explained earlier, it really is just as simple as clipping the positives from one row into the negatives of the next, using these little connectors. So just like that.
Immediately explodes.
There we go, that's one connection done. Just got 4 of them to do on each side of each module. Let's just take a quick minute to appreciate how dodgy and dangerous this is, especially with all the
okay, we are addressing that. Okay.
wires and stuff hanging out. Yeah, I am paying very close attention to what I do right now, and I definitely do not recommend anyone ever builds a battery pack like this. So now we've hooked up each half in series, we can measure the voltage across each half to make sure it's around what we would expect. There we go, 25 volts on this half. That's looking pretty good.
Okay.
And another 25 volts on this half. So that's fantastic, really. It tells us that everything is perfectly as it should be. So now we've just got to connect both of these halves together. So we're going to connect them at the bottom, and then this is going to be our negative, and this side is going to be our positive. So we'll just have our connector up here. Now let's get on to how we're going to link up these two halves.
So we could use the clips to make a direct connection between the two halves, therefore putting them both in series. But we could also kill 2 birds with one stone by linking them together with a big chunky fuse. You see, if something goes wrong and we draw too much power from the battery, the fuse will pop, disconnecting this link between them and not allowing any more power draw. But by having a fuse in the middle, It means that even if there's a fault on the inside of the battery, where the two halves internally short together, then the fuse will also pop and save the day. So I'm definitely going to do this.
Okay.
And there we go. Just like that.
We now have
we've
a
got
50
volts.
volt bomb.
Absolutely spot on.
And finally, it is mega important that any battery pack has a battery management system,
Uh-huh.
or BMS. This will monitor each parallel row of cells and make sure everything's healthy. If you don't do this, then there's a good chance that it'll explode, as I've seen in the past. To wire up the BMS, you have to connect a wire to each of the parallel rows, so that the BMS can monitor each row's voltage. Fortunately, I've already got a huge BMS from the 50-mile-an-hour mobility scooter video. So let's get that moved
I'm sorry, the what video?
so that the BMS can monitor each row's voltage. Fortunately, I've already got a huge BMS from the 50-mile-an-hour mobility scooter video. So let's get that moved over.
Speaking of mobility scooters, have you seen like how fast the e-scooters that don't have speed limiters can go? Some of them can go highway speeds on a fucking scooter. I don't know who would be stupid enough to go highway speeds on a fucking scooter. At least, bare minimum, some people are wearing like motorbike gear. But if you're doing that without motorbike gear, good luck. Good luck.
I've added a bunch of clips to the series connections that take in 3 wires, which means that we can just clip in all of the wires from the BMS. And then finally, we add a big fat 200 amp connector to the top. Right, battery management system is all completely hooked up now, and I've done
Now we truly do have a death device.
Right, battery 200 amp connector.
Let's just hear that again.
And then finally, we add a big fat 200 amp connector to the top.
Yeah. Don't touch that one. Do not touch that one.
Right, battery management system is all completely hooked up now.
Hello,
I've doubled and
hello.
triple checked all the
We're
connections.
watching a guy build a bomb. Also known as a battery bank, or like a power bank made of 500 lithium-ion cells from disposable vapes that he's going to plug into his house.
And it does look fine. So hopefully we're not going to be releasing any magic smoke, but there's only one way to find out. So if I hold this button,
Uh-huh.
I think they are good beeps. Let's see what's coming out of this thing. Look at that. 50 volts. Yeah, this thing is completely working. Battery management system's happy.
No
I think we're
boom.
ready to start connecting this thing to the workshop. Now, unfortunately, our battery pack puts out around 50 volts DC, and you can't power any mains household appliances with this. For that, you need a voltage output of around 240 volts AC. So what we're going to need is a thing called an inverter to convert between these two voltages. Like this one, for example. So my house gets its power from the grid, which then also feeds power to the workshop.
Sure.
But we can disconnect the workshop from the house and use the battery
Yeah,
pack.
very important that you do this, because otherwise you are going to have the police rock up at your house. This is a problem that, Okay, so are you aware of a suicide cable? Google had a warning for me when I looked up suicide. This is a suicide cable. Do you understand why this is a problem? So basically, This is a male-to-male cable. There are no situations under normal cases. Okay, so when you plug in an extension cord, one side you have a male connector that goes into the wall. The other side is a female connector. That is what you connect devices with. Here we have exposed prongs. So if you plug this into your mains, this is mains coming out right here. This is, you touch these, you die. Now, what people will do is they will buy these, and during a power, or they'll make them, because no sensible place sells these. They will plug one side into the wall, and the other side into a generator. Now, this will power the house, but what it will also do is, because you are still connected to the outside network, it will send power from your house back out to the power lines. And if there's a power outage, there's probably people working on these lines. So what you've done is now electrified what people assume are dead lines. This is how you get the police sent to your house. That is why this is very important. Now, there is a way to connect a generator to your house, but you have to specifically have the ability to disconnect your property from the network. If you don't have that, you are going to kill someone. Probably yourself, but someone will die. And that's why this is very important. Being able to disconnect, if you're going to do something stupid like this, being able to disconnect the house from the network and just do it within the circuit. I thought it tripped, so it will probably also do that. That will probably also happen. That's the best case. That is the best case scenario. Wait, then how do people feed their solar panels back into the network? When you get solar panels installed in your house, they specifically set it up so that it can be done. Like, this is why you don't install your own solar panels. You have an electrician who specifically sets it up so the power is going to the correct location. Also, this is another thing. When you lose power, you will in most cases, when you lose power, you don't actually have your solar power running either. So a lot of people assume when they have solar panel and they have a battery that they can run the house off grid. So the power goes out, but they assume they should have power because of the solar. That actually doesn't work. You actually have to specifically have your property set up to allow the property to run off grid. It's not just a thing that inherently comes with having solar and having a battery.
An inverter to then power the workshop. Theoretically, we could also disconnect the house from the grid and then feed power from the inverter into the house as well, which means everything will be completely off grid.
I like the theoretically.
Right, so we've got the battery all connected to the inverter, and the inverter should be hooked up to the workshop now. So inside this box, we can see that we're getting power from the house at the moment. So if I turn this off, there we go, no power, very spooky. And then here, this is the circuit breaker for the inverter. So let's turn that on.
Okay.
Right, now if we switch on the power of this thing, there we go. Now we'll just have to give it a few seconds to boot up. Right, so we can see we've got 49.2 on the input and 229 on the output. This is what we want to see. So theoretically, if I turn this, oh, look at that. This workshop is now being completely powered 100% from these vape cells. This is crazy. All right, there we go. Got the oscilloscope going.
I've seen some cars can power a house while acting as big-ass battery. Yeah, I am... Yeah. That's another case. It's like this, where you want the house to be set up for it. I'm sure people do things they shouldn't be doing, but you definitely want it to be set up to do so.
Got my extractor fan, power supplies, everything. All of this powered 100% by disposable vape batteries that would otherwise be in the landfill most likely. So we can see on the BMS app that, yeah, we're drawing about 200 watts from the battery. And here we go, the inverter, yep, 200 watts of power draw. This is just amazing, isn't it? Okay, now for the test we're all waiting for. Can we actually feed power back into the house? So we're in the house now, and I've turned off a big switch outside, and we've turned off the main switch here. So we have absolutely no power at the moment.
Yeah. Very important
Nothing.
switch.
All right, so we're back in the workshop. We've got the inverter all powered again. So if you flip this, okay, that's what we expect. That's power going to the workshop. Now if we flip this, oh, the fan's kicked in. It's certainly working harder. Let's go and take a look. Check this out. So we're still completely off grid here. Main switch is off. And the microwave is absolutely happy. Got lights working.
That's actually crazy.
Let's
This
see what else
works.
is working out here. Yep, extractor fans all good. And I tell you what, I bet we can even make ourselves a brew.
Mate, if you want to fucking... Do you want to, like, fill up your kettle before you boil the water?
Yep, there we go. Working absolutely perfectly. So to answer the question, can you power a whole house using just disposable vape cells that are thrown away in the millions? Then yes, you absolutely can. Right, and check this out. I can even edit this exact video using the power of disposable vapes. I fully cannot wrap my head around this.
So there we have it. At the moment, I can charge the battery pack from the grid at night when electricity prices are nice and cheap, but I bet we could easily whack some solar panels on the workshop and go entirely off grid. So let me know if that's something you'd want to see. If you enjoyed watching this video, then drop it a like to help the algorithm and also spread some awareness of this ridiculous source of e-waste. See you in the next one.
I knew there'd have to be something that goes wrong somewhere. What a dumb video, cinema. I agree. I completely agree. That was a great video. I've never seen this channel before. Yeah. Yeah, that was fun.